Let's do some leetcode. So I'm doing leetcode 98, validate binary search tree. Given the root of a binary tree, determine if it's a valid BST. A valid BST is defined as follows. Left subtree of a node contains only nodes with keys strictly less than the node's key. The right subtree of a node contains only nodes with keys strictly greater than the node's key. Both the left and right subtrees must also be BSTs. So we see in example 1, we have 2 and 3. Everything in the left subtree has to be less than the root. Everything in the right subtree has to be greater than the root. So here, the root is 2. Everything in the left subtree, 1 is less than, so that's true. Everything in the right side of the root, 2, has to be greater than, so 3 is greater than 2, that's true. Thus, this returns true. Example 2, we see that 1 is less than 5, so that's true. But 4 is not greater than 5, so 5's right subtree returns false. So this is false. So what we have to do is basically recurse through every node. Once we reach the base case, which is an empty node, we return true, which means that we successfully validated everything before that. So here we're at 2, recurse 2's left, 1. We check, is 1 less than 2? Yes, it is. Then we recurse 1's left and right children. Since we hit base case, this is true. Therefore, this left side is true. 2's right side, validate if, or check if 3 is greater than 2. It is. Then we recurse 3's children. That would return true back up. Thus, 2's right side is true. And then we check, is 2's left and 2 right both true? If so, then this whole tree is true. That's a BST. And we just keep recursing each node like that. So first base case would be if not root, then we just return true because an empty tree would be a BST. And I'm going to set the left and right bounds. So min val would be negative infinity because this is what I'm first passing in into my DFS function. And max val would be float infinity. So in my DFS, I'm going to pass in the current node, left bound and right bound. So for example, if I start my DFS at 2, the left and right bounds would be negative infinity and infinity. That's within bounds, so that's true. Then I'm going to start the recursion. And when I go to my left side, I'm going to pass in the parent. The parent would be the right bound, and then the left bound would be negative infinity. But if we go on the right side, the left bound would be the parent, the right bound would be infinity. So here we're going to do if not root node, return true. This means that everything before was validated, and so we should return true back up to the parent. Here we're going to do some work. So that's the validation part. We're going to check if left bound is less than no.val is less than right bound. If this is not true, then we're just going to return false. And if it does not hit this condition, then that means we have successfully validated this current node. And so we can recurse now. So left would be DFS no dot left. Left bound would be left bound would be left bound. Right bound would be no dot val. Because we go left, yeah, right. Right would be no dot val. And opposite for right side. Left bound would be no dot val. Right bound would be right bound. And we're gonna check if these two return true. Return. If left and right, then we return true. If this is not true, then we return false again. You can just combine this into left and right. This will return true if both are true. If it's not, then if one of them is false, then it returns false. And we just return DFS root min val, which is the left bound. We're starting the DFS. Right bound would be the max val. Okay. Time complexity is O of n, which is check every node. Space complexity is the recursion stack, which is O of n.